In question 11a, we have to find the coordinates of the minimum point of the curve y equals to 9 upon 4x square minus 12x plus 8. Now, when it is talking about the minimum point, it means that the dy dx will be equals to 0. So in the first step, we'll find an expression for dy dx. So dy dx will be equals to, we'll multiply the 2 by 9, that will become 18 upon 4 and will decrease the power by 1. Differentiating minus 12x, that will become a minus 12, and differentiating 18, that will become a 0. Now substituting dy dx equals to 0, we'll get 0 equals to 18x upon 4 minus 12. Simplifying, this will be 18x upon 4 equals to 12. So x will be equals to 48 upon 18, which you can simplify to write it as, so dividing by 2, that will become 24 upon 9. Now, as we have to find the coordinates, which means we have to find the y coordinate as well, we'll substitute the x value, which is 24 upon 9, in place of x into the equation. So this will be 9 upon 4 into 24 upon 9 whole squared minus 12 into 24 upon 9 plus 18. Substituting this in the calculator, the value of y will be equals to positive 2. In part B, the diagram shows a curve with the equation y equals to 9 upon 4x squared minus 12x plus 18, and y equals to 18 minus 3 upon 8x to the power 5 upon 2. The curves intersect at the point 0, 18 and 4, 6. In part B, we have to find the area of the shaded region. Now, to find the area of the shaded region, first we'll find the area under the curve with the equation y equals to 18 minus 3 upon 8x to the power ax to the power 5.2. Now we know that they are intersecting at the point 0 and 4. So this point will be 4. Integrating and substituting the limits for this equation will give us this total area. And then integrating 9 upon 4x square minus 12x plus 18 will give us the area under the graph for this particular equation, which is the area in the green shaded part. Then finally we'll subtract the two areas to get the area for the shaded region. Now to find the area, we'll first integrate both of the equations. So to find area, that will be equals to integral of 4, and the limits will be 4 and 0. The first equation is 18 minus 3 upon 8x to the power 5 upon 2. And we'll subtract it from the area under the curve of the equation 9 upon 4x squared minus 12x plus 18. So integrating 18, that will become 18x minus integrating 3 upon 8x to the power 5 upon 2. So this will be 3 upon 8, increasing 5 upon 2 by 1, that becomes 7 upon 2, and we'll divide it by the new power, which is 7 upon 2. Now integrating the second equation, that will become 9x cubed upon 12. This will become minus 12x squared upon 2, and integrating 18, that will become an 18x. You can simplify this as to write it as 2 1 times and 2 4 times, so that the denominator will become 28. So we can simplify the first equation, write it as 18x minus 3 upon 28 x to the power 7 upon 2. We can simplify this to write it as 3 upon 4 x to the power 3. And this will become minus 6x squared plus 18x. Now substituting x equals to 4 as it is upper limit. So this will become 18 into 4 minus 3 upon 28 into 4 to the power 7 upon 2. And if we substitute x equals to 0 in both of the terms, it will become a 0. So the difference will be a 0. So we will just use a value of 4. And now in the second equation, we'll substitute x equals to 4. So this will be 3 upon 4 into 4 cube minus 6 into 4 squared plus 18 into 4. So 18 times 4 over here. And again, if we substitute x equals to 0 in all of these three terms, it will be a 0. So we can leave it as it is. So 18 into 4 is 72 minus 3, 4 to the power 7 upon 2. So square root of 4 is 2 and 2 power 7 is 128 upon 28. Minus, so this will become 3 upon 4 into 64 minus 6 into 16. So this will be 6 times 16, and 18 times 4 will become, so this minus will make this a positive, and minus plus will just make this a negative. So this will be a negative 72. 72 and 72 will cancel. Substituting these values in the calculator, the final answer for the area will be equals to 240 upon 7. Or in decimal, we can also write this as 34.3. So the area of the shaded region will be 240 upon 7 or 34.3. In part C, a point is moving along the curve y equals to 18 minus 3 upon 8x to the power 5 upon 2 in such a way that the x coordinate is increasing at a constant rate of 2 units per second, which means that the value for dx by dt is 2. We have to find the rate at which the y coordinate is changing, which means we have to find the value for dy dt when x equals to 4. Now, the relationship between dy dt and dx dt is given by the equation dy dt equals to dy by dx multiplied by dx by dt. We already have dx by dt, so in the first step, we'll find dy by dx as y is equals to 18 minus 3 upon 8 x to the power 5 upon 2. Differentiating this will become dy by dx will be equals to, so 5 upon 2 will multiply by minus 3 upon 8. So 5 upon 2 will multiply by minus 3 upon 8. And this will become x to the power. So decreasing the power by 1. 5 upon 2 minus 1, that will become 3 upon 2. So this will become minus 15 upon 16. And then as the value of x will be 4, so we'll write it as 4 to the power 3 upon 2. Substituting this in the calculator, the value for dy dx, so we'll get minus 15 upon 16, and 4 square root is 2 and 2 cube is 8. So this will be 8. So this will become 8 one time and 8 two times. So this will be minus 15 upon 2. So the value of dy dx is minus 15 upon 2. The value for dx by dt was 2. 2 and 2 will cancel out. So the value for dy dt, or the rate of change of phi, will be equals to negative 15.